Advent of Code 2022, day 15. Beacon exclusion zone. You felt the ground rumble again as a distress signal leads you to a large network of subterranean tunnels. You don't have time to search them all, but you don't need to. Your pack contains a set of little sensors. Okay. Once a sensor finds what it thinks will give it a good reading, it touches itself. Sensor being Manhattan distance. Okay, some of their absolute differences. Okay, so let's try to parse this. So sensor data equals well, line. Well, okay, so raw sensor in file data dot split by new line, and then it should be okay, parse sensor and then versus raw sensor. Okay. Raw sensor split. Okay, raw sensor coordinate equals left dot split by at 1, and then raw sensor raw beacon content coordinate is right split. Let's say a the return okay, return parse coordinate raw sensor coordinate and parse for raw. Well, okay, raw sensor coordinate, and then the parse coordinate. Well, technically parse coordinates. And then here it's like left, right equals raw coordinates dot split by that, and then return int left 0, 1, 2. Right, 2. So print sensor data. Okay, looks good to me. So consider sensor is a 218 classic beacon to it is -2. Drawing sensors as a beacon speed buffer sensor. This looks like this. Right. None of the detected beacons seem to be producing the distress signal, so you'll need to work out where the distress beacon is by around where it isn't. For now, keep things simple by counting their positions where a beacon can possibly be along just a single row. Suppose you have an arrangement of beacons and sensors like in the example above, just in the row where y equals 10, you'd like to count where the number of positions. To count the number of positions a beacon cannot possibly exist, the coverage from all sensors near that row looks like this. In this example, in the row where y equals 10, there are 26 positions where the beacon cannot be present. Consult report from the row where y equals 2, whatever, how many positions cannot contain a beacon. So okay. Cannot, how many positions cannot contain in a row where? Okay, so okay. So import collections. And then okay, map equals collections dot default dict. With the value false. And then for Okay, so basically for sensor and first beacon in sensor data. Okay, so basically distance equals apps sensor minus sensor. Well, wait. What did I do? So day 15. So distance is like sensors 0 plus sensor. No. Nearest beacon 0 plus so, and now if I run it, okay, I have the distances, and then for, I don't know, x in range, sensor 0 minus distance and sensor 1 plus distance plus 1. And now the same for y. Oh, this, yeah. And then if well, I guess I could just put this so basically, okay, I don't know, dx dy, if dx plus dy is bigger than distance, then we continue, otherwise map sensor 0 plus dx and sensor 1 plus dy is true. Now the end, let's print map. Oh, wait, what? Oh, wow. Okay, so it's like minus distance. Okay. And I guess if Okay. So now those are all the places where it should not be for this example. And now if I go for okay, print some, and then okay, for x and y in map.keys, and then so it's 1 x and y in map.keys if map, well, if y equals 10. Hmm. Why? Oh, okay. So print some. It's 161. How's that possible? Okay, so matching places in a row equals. Oh, I think that the only issue is that I rotated the coordinates. No, still completely wrong. Even though the logic seems to be valid, so maybe there is a problem with how the distance is counted. But Manhattan geometry seems fine. Oh, that's horrible. 37. It should be something's still wrong. Like this should be fine. How did it go all the way to 28 though? Okay. Suppose you have an arrangement of beacons and sensor. I don't know. I want to print. Okay. For y in range. No, minus 10 to 20. Y equals that. Okay, for x in range. Minus 10 to 20. Line plus c equals dot. Line plus equals c. And did I do again? Day 15 solve. Okay, print line. Where's oh, I forgot line plus equals c, and then okay, if map x y then c equals that. So that doesn't really look correct to me. Let's try to look at just one sensor. That's weird. Okay, print dx dy. Actually, print dx dy. Okay, minus 7, 7, and 6, and 5. And then but okay, it should be, so the distance should be actually less. What was it in the example? 26. So that's not it. But okay, certainly the distance should be like that minus 1. Right? How's it 30 now? So this is kind of weird. Okay. I guess. Okay, let's make a sensor positions equals set and then x0 or x in sensor data, and then beacon positions x1 sensor data. Then here, okay, if x y in sensor positions, then c equals s x y beacon positions is b. And now let's see just the first one. So if I do this, it should be like a rectangular shape. Okay, so this is the sensor. And then... oh, okay, so this should be abs dx plus abs di. Yep, dy. Yes, okay, so now let's do it for all of them. And let's get the final result. But it's 80, it should be 26. Why? Okay, maybe if map xy, if map xy is okay. Why? It's 23, but it should be 26. So in the end, that was wrong. No, it's 27. Okay, 26. So maybe now it's correct. So get your puzzle input. Day 15. Place. Okay. Jeez. Ooh, that's a problem. So these are like very, very, very far away from... Okay. And there's few of them actually, so I did the completely wrong algorithm. Kind of. Well... Mm, mm, okay. So basically, don't need this part. Well, I kind of do, but it's like, okay, for sensor nearest beacon sensor data. Oh, I don't know. Is there like a way to make this fast without... I don't know. I mean, is it way too big? Yeah. I mean, for now, I can put like if well, okay, like here, I can just put dy equals 10. But it's not true. Dy is not 10. It should be whatever it takes to make... Okay, dy equals basically 10 minus... Okay, there's the sensor. Sensor coordinate. Okay, so if so it's like minus sensor 1 plus 10 or something like that. But now let's do it for the sample input again to see if it still works. So that even looks correct. So what's the matter? Ah, okay. No, not okay. What's the matter? I mean, actually, it's just like, okay, basically, but not really. Okay, coordinates. Okay, matching coordinates. Well set. Matching coordinates dot add this. $27. Is it 27? I mean, I can still say map. Hmm. Why? Why is it 27? These are identical. How am I counting wrong? Wait. Cannot contain. Ah, the position that does contain a beacon should be. Okay. So basically, if new coordinate not in beacon coordinates, beacon positions, then, and now 26, okay. So now I put back the big input and do it for line, what is it, 20 million or something? Okay. It's slow. How many are there? 29. Okay, I guess I can wait for 29. But it shouldn't be this slow. I guess I'm still going through those entire aligns. I hope it's correct. It's not the right answer, it's too high. Turn to day 15. It's too high. Oh, by the way, if I don't put these, is it faster? Not really. Yeah, it just has to go through all those positions. It's too high. Why? It's 23. It's not good. Ah, wait, does that won't change anything now? dy dx. There are 26 positions where beacon cannot be present. Consult the report from the sensors users deployed in the row where I equals blah blah blah. How many positions cannot contain a beacon? So suppose you have an arrangement of beacons and sensors like 10, not possibly exist. Coverage from all the sensors near that row looks like this. Wait, the sensor position can also not be beacon, but I don't know. I mean, that would be the closest to that sensor. Well, how? Oh. And coordinate login sensor positions. Okay, it should be 26, but now if I put okay, what I did wrong was instead of 10, I should have put the 10. I should have put the 10, or the 20 million or whatever. I should have put it here. And now I have to wait again. It does maybe seem to be a little bit faster actually. The right answer. Your handheld device indicate, okay, what is tuning frequency? Twisted distress. Okay, your handheld device indicates that the distress signal is coming from a beacon nearby. The distress beacon is not detected by any sensor, but the distress beacon must have X and Y coordinates, each no lower than 0 and no larger than whatever large number that is. To isolate the distress beacon signal, you need to determine its tuning frequency. Okay, so tuning frequency is X times this number plus Y. In the example above, the search space is smaller. Instead, the X and Y coordinates can each be at most 20, which is, okay, the tuning. Okay. So, to isolate the distress beacon signal, you need to determine its tuning frequency, which can be found. It's not detected by the sensor, but it's no lower. Find the only possible position for that distress beacon. What is its tuning frequency? I mean, how long does it take to... How long does it take to go from... No? For X in range, 0 big number plus 1. For Y in range, pass. Let's just do nothing. Okay, let's start with printing X. Okay, that's insanely slow. Okay, so I need to find some kind of trick, I guess. That will actually take forever. So somehow it has to be like, but that's a big. How can I get... Okay, your handheld device indicates that the distress signal is coming from a beacon nearby. The distress beacon is not detected by any sensor, but a distress beacon must have X and Y coordinates each no lower than 0, no larger than... What is it, 40 million? Just 4 million. To isolate the distress beacon signal, you need to determine its tuning frequency, which can be found by multiplying its X coordinate by... and then adding to its Y coordinate. But okay, basically... I don't know. It's only one position that's... Then it should just be... Okay. Should say it's 0, 20. So this is that only place. But how can I kind of model this without... Okay, so it will be only one place. It will not be... So basically it will be the only one in that column. It will be the only one in that row. Maybe if I count... but still it will need... Will need so many things. If I counted like how many there are in each column row, but still for that I have to do that whole iteration thing. I mean, it must be on the edge of at least one of the beacon thingy, well, one of the radiuses or whatever. So maybe if I go, okay, around the radiuses and I put all the coordinates that are one too far into a set, and I also put all the coordinates that are just the right distance. So then the problem becomes, how do I make the... Like, how do I make an iteration? It's like... How do I calculate? How do I get like a formula for these lines? So it's mirrored across two axes, and I guess the length. Okay, the length of this. Well, not really the length, but the number of rows that there are in it. It's the distance between this and that. So 7 and minus 2. So I can have I have like a formula for I can have a formula for starting at like distance and going to 0, and each time I remove one from distance I add it to the other coordinate. So basically, instead of this, okay, I have the distance, so for I don't know, I in range distance plus 1, then I can, okay, in map I can add, okay, so new coordinate, so okay, in the map I can add get BA, okay. Oh shit, how did I not do that? So it should be okay, dx and dy is true, and then dx equals I, and dy equals distance minus I. And then here I just need to do it also with minus to mirror them across all axes. And I should just, if I run the code, I should just see the outlines. Hey, that seems to be working. So I'm getting just the outlines, and then I guess for, okay, so basically potential solutions is set. Okay, so this is like potential solution impossible solutions. So this, instead of that, I should be adding them. Okay. So impossible solutions dot add. Oh. Oh. No. Obviously now printing the map makes no sense. And then here I do the same thing again, but I add +1, and here it's potential solutions, and now print, okay, potential solutions, impossible solutions. Okay, so basically potential solutions minus impossible okay, Python set difference. Okay, so now the problem is that no potential solutions. Okay, filtered potential solutions equals set. Okay, for x in potentials x. Okay, x for x in potential solutions if x. Okay, big number. Big number, and now it's 20. Okay, so if x, y. Okay, so if 0 is less than equal, then x0 less than equal to big number, and the same for, no, what? And the same for the other coordinate. And now we get remove impossible, but it's still so many. Which I don't get it, because there's so many like negative coordinate things. Oh, I did not, okay. Filtered potential solutions. It's still too many, why? Okay, let's see. For the map, maybe I put dot here, and then, okay, impossible solution, so map. Okay. Then here, oh well, I guess it's just the same. Except here we add a question mark. And then I can print map again, but I will put like C equals map. Okay, basically just line plus equals map x, y. Oh. Well, still they need to be... they could be covered by... I mean, if I print only to 0 to 21 and 0 to 21. Okay, there's still a lot of question mark places there. And I put, okay, distance, potential solutions, yes. Distance, okay. So I mean, okay, the solution still has to be not too close to any of the beacons, I guess. So filtered potential solutions. And then, okay, so basically, and not too close x. So basically, okay, if not too close x, return true. Then for sensor beacon in sensor data, you can again get the distance. And then distance from x. So it's like sensors near beacon. So this should be just x, x. And then if distance from x is less than distance, or less than distance, then turn false. Now it's empty. Wait. Oh, okay. Oh, it's only one coordinate, and that is, for that example, 14, 11. Oh my god. So solution e equals dot pop, and then print solution C 13. Okay, x coordinate. Solution C 0 times this big number plus solution C1. Okay, that looks correct. So now doing the same for big input. Okay, it is a problem. It's still slow-ish. And maybe it's not impossible to... Oh, but then here there is the problem. Okay. Because it's still like iteration over those 40,000 things. At 4 million or whatever. Yeah, that's iteration over all of that. But there's no real way to avoid that, I guess. Well, maybe there is a way. Like by turning the whole thing into like a big equation or something like that. Anyway, let's try to just wait for the solution. Okay, so actually I ran into an issue. My computer crashed because actually this whole thing uses a lot of memory. Like, it's one thing that it's kind of slow to render, but actually it uses like, it crashed because it was using like 40 or 60 GB of RAM. So even the swap file was full and such. So it completely crashed my entire computer, and I'm thinking that maybe there could be an easy-ish way to solve it. I mean, there is this part where everything is like being filtered here. So like we store all the things, even though, and we're removing it. We're moving it here. So maybe here, and I'm thinking also to kind of do okay, so basically let's say that I uncomment this part for now, and I just calculate the potential solutions first, where it will be kind of filtered already by these, and then I'm just going to remove stuff from here, from that, with this second iteration. And okay, I guess this is not needed at all, actually. Potential solutions. So now it should be kind of faster because it's just doing half the work. Oh, but I did not put the print. It's weird, I think I should have put the print. It's quite a bit faster. So then I guess, okay, candidates equals this. Ooh, what did I do here? What did I do? I don't get it. Okay, because I block copied. I don't know how to auto format this. Ah, okay. So now it should be not saving anything to memory. Okay, and then I guess for candidate in candidates, if not too close. Okay, if not too close, then continue. And then, okay, basically potential solutions dot add candidate. And then also let's do this like filtering. Kind of like, okay, if okay, big number should be like here. And okay, if dx okay, if not 0 less than equal, then dx 0 less than equal big number, the same. Continue. So this is not dx, it's candidate and candidate 1. Okay, it's kind of increasing with the memory usage. No, wait. That's OBS. This is okay. It's very low memory usage, but it's very slow. Okay, so maybe it's because this part, I think if I don't include that, it will be faster. And it's also increasing memory usage faster. It's already 3%, 3.6%, 3.8%. But 7%, 7.7%. 12%? 11%. Okay. 15%. I mean, I think that by this point, last time it already crashed, so. We have only 29, so it should be almost done. I think it should not crash, so now I have to kill it because I want to fix the other stuff, so it still needs to do another round. Does it actually need to do another round? I mean, basically, if I go through, okay, for potential solution E, set potential solutions. And okay, if not too close, potential solution, then potential solutions that remove potential solution and continue. And now if I go, okay, day 15 input, so I put the demo data. Okay, it still has okay, if to okay, return it's less than or equal, then okay, return true, otherwise return false. Okay, if too close, okay, print potential solutions C equals potential solutions dot pop. So there's still way too many coordinates there. Okay, but here it's a big number. It's actually like 20. Was that the actual value? Okay, yes, that was the actual solution. So now if I put back the big number to be that, if I put back the big number to be that, I put back this, now I should ideally get the correct result. Okay, I want to progress. I want to progress here. Okay, enumerate. Come on. Okay, print. Okay, that will be I divided by 29 times 100. 3%. 6%. 10%. So I hope there are no bugs in this one. Because yeah, now I'll have to wait for a while. And hopefully it will not run out of memory either. $75, 79%. I mean, if I made the percentage calculation correctly, but I think I did. It's 29 items. So there should be 2 more. Will I run out of memory? No. I think no. Six. Is it stuck? What's going on with the last or penultimate sensor or whatever? Or is it just doing some wild garbage collection or whatever? What is going on here? It's using increasing amounts of memory. And I'm thinking that is it possible to somehow like rotate the coordinates and turn them into rectangles and I don't know. Or again somehow just look at the columns and rows or whatever. But anyways, I mean, now I should be getting the result. I don't know what's going on. I'm wondering if it will ever finish. So I guess, I mean, in the meantime, maybe I could try, because there is something called Numba, which is supposed to be a Python like compiler. So I'm thinking, okay, that by the way, what's my Python version? So if I upgrade Python, which should be no. Oh no, so Python. Okay, Python. It's not yet the stable release, I guess. Okay. So yeah, maybe I do like poetry init. Yes, poetry. Dev number. Oh, but in the meantime, it actually finished. So if it's the correct result, yes, it is the correct result. Nice. So I don't need number.